Hello, viewers. In today's session, we are going to discuss one important problem related to matrices. So, here we are going to have this problem in which we are given two matrices A and B, and we have to verify the reversal law of transpose for these two matrices A and B, right? So let us first briefly see the meaning of transpose of a matrix, and then we'll see the statement of the reversal law of transpose of two matrices. Now let us consider two matrices A and B, right? And if the two matrices A and B are such that their product is defined, then the transpose of the product of the matrix A and B is given by the reversal rule, and the reversal rule says that the transpose of the product of matrices A and B is equal to the transpose of the matrix B times the transpose of the matrix A, right? So this rule is known as the reversal rule for transpose. So now let us consider an example. Suppose we have a matrix P, right? And here we are taking the matrix P as 3 cross 2. So here we have three rows and two columns. So suppose the elements are minus 2, 4, minus 1, 0, 1, and 3, right? So here we have three rows and two columns. Now the transpose of this matrix P is defined by interchanging the rows into columns and columns into rows, right? So the transpose of a matrix is denoted by here we'll write P raised to T, or sometimes we can also write P dash or P prime to denote the transpose matrix. So here the transpose of this matrix P is given by interchanging the rows into columns and columns into rows. So we have minus 2, 4, because here we have this row. So now in the transpose matrix, this row becomes the column, and then we have similarly for these two rows, we have minus 1, 0, then we have 1 and 3, right? So the original matrix P was 3 cross 2, the order was 3 cross 2, and here we have now two rows and three columns, right? So this is how we define the transpose of a matrix. So now let us come to our problem in which we are given two matrices A and B, and here we can see that the matrix A is a 3 cross 1 matrix, right? So we have three rows and one column, and the matrix B has one row and two columns. So now the matrices A and B are conformable for multiplication, right? It means the product of the matrix A and B is defined, because see here the number of rows are 3 and number of columns are 1, and here the number of rows are 1 and number of columns are 2, right? And we know that the product of two matrices A and B is defined if the number of columns of matrix A are equal to the number of rows of matrix B. So here the number of columns are 1, here the number of rows are 1. So the product A times B is defined, right? So let us first find out the product AB. So here we have 3 minus 2 minus 1, and then we have here 2 and 4. So here we have 3 cross 1 matrix. Here we have 1 cross 2 matrix. So when we multiply these two matrices, we'll get a 3 cross 2 matrix, right? It means 3 rows and 2 columns. So now let us find out the product of two matrices. Now see here, first we'll multiply 3 times 2, then we'll have minus 2 times 2, and then we have minus 1 times 2, right? And then in the second column we'll have 3 times 4, then we have minus 2 times 4, and then we have minus 1 times 4. So now we have 6 minus 4 minus 2, and here we have 12 minus 8 and minus 4, right? So the product AB is given by this 3 cross 2 matrix. So now we have to find the transpose of the product of the matrix A and B, right? So we can now write the transpose of AB as here we have 6 minus 4 minus 2, then we have 12 minus 8 minus 4, and here we have transpose, right? So now the transpose of this matrix can be obtained by interchanging the rows into columns and columns into rows. So here we have 612 as the first row. So now in the transpose matrix, it will become the first column. So we have 612, then we have minus 4, minus 8, then we have minus 2 and minus 4, right? So here the left hand side, that is the transpose of the product AB, is now given by this matrix, and this matrix is 2 cross 3. That is, the order is 2 cross 3. So we have 2 rows and 3 columns. So now let us find out the right hand side. So for obtaining the right hand side, we have to find the transpose of the matrix B, transpose of the matrix A, and then the product, right? So now we have B transpose is given by B is here 2 4, and the transpose is given by the column matrix, that is 2 4, right? Because here we have 1 cross 2 matrix, the transpose becomes the 2 cross 1 matrix, that is 2 rows and 1 column. And similarly, the transpose of the matrix A is given by 3 minus 2 minus 1 transpose, and here we have 3 cross 1 order. So now the transpose gives us 1 row, that is 3 minus 2 minus 1, and 1 row and 3 columns. So the order is 1 cross 3, right? So now we need the product B transpose times A transpose. So we can now write B transpose, A transpose, and here B is 2 4, and B transpose is 2 4, and A transpose is 3 minus 2 minus 1, right? So here we have 2 cross 1 matrix, here we have 1 cross 3. So now the resulting matrix would be 2 cross 3, right? So 2 rows and 3 columns. So now let us multiply these two matrices. Now see, here we have 2, right? So 2 times 3, here we'll get 2 times 3, then we have 4 times 3, and then we have 2 times minus 2, here we have 2 times minus 2, then we have 4 times minus 2, and then we can write here 2 cross 3, and then we have 2 times minus 1, and then 4 times minus 1, right? So now we have the matrix 2 cross 3. So this is 2 3s are 6, this is 12, 4 3s are 12. Here we have minus 4, then we have minus 8, and then we have here 2 times 1 minus 2, and then we have 4 times minus 1 minus 4, right? So the product BT and AT is given by this matrix. So viewers, from this calculation, we arrived at the result that the value of this matrix is 6, 12, minus 4, minus 8, minus 2, minus 4. And the value of this matrix is again the same matrix, that is 6, 12, 6, 12, minus 4, minus 8, minus 2, minus 4, right? So we can claim that the transpose of the product of A and B is given by B transpose times A transpose, right? And this is a very important rule in matrices, which is known as reversal law of transpose. And this is how we can verify this rule by using these two matrices A and B, right? So this rule is true for all matrices A and B, which are conformable for multiplication, like the product A and B should be defined, and similarly the product B transpose and A transpose should also be defined.